September 23rd, 1999. NASA's Mars Climate Orbiter disappears. The spacecraft burns up in the Martian atmosphere. $327 million vaporize in seconds. 9 months of work erased. The cause? A simple math error. Two teams used different measurement units. One team calculated in metric, the other used imperial. No one caught the mistake. The orbiter flew too close to Mars. Atmospheric friction destroyed it. This is the story of NASA's most expensive conversion error. How did the world's leading space agency make such a basic mistake? December 11th, 1998. Mars Climate Orbiter launches from Cape Canaveral. The mission cost $327.6 million. NASA designed it to study Martian weather and climate. The orbiter would map water vapor and dust in the atmosphere. It would also serve as a communications relay. Engineers expected a 286-day journey to Mars. The spacecraft carried two main instruments: a camera to photograph the surface, a spectrometer to analyze atmospheric composition. The mission was part of NASA's Mars Surveyor program. Scientists planned to orbit Mars for 1 Martian year. That equals 687 Earth days. Everything looked perfect at launch. The spacecraft traveled through space for 9 months. Ground controllers tracked its position constantly. They sent navigation commands regularly. These commands adjusted the flight path. Small rocket thrusts kept the orbiter on course. Lockheed Martin built the spacecraft in Denver. They provided the navigation software. NASA's Jet Propulsion Laboratory managed the mission. JPL engineers calculated a trajectory. Both teams worked separately on different systems. Communication happened through data files. The files contained thrust information. This data was critical for accurate navigation. Nobody verified the measurement units in these files. The navigation system required precise calculations. Small errors compound over millions of miles. Lockheed Martin's software calculated thruster force. It output data in pound-force seconds. This is an imperial unit. JPL software expected Newton seconds. This is a metric unit. 1 pound force equals 4.45 newtons. The error was significant. Every thrust command was off by this factor. The spacecraft drifted from its intended path. It moved closer to Mars than planned. Ground controllers noticed some anomalies. Trajectory data showed unexpected variations. Engineers reviewed the numbers. They attributed differences to solar radiation pressure. Nobody questioned the fundamental calculations. August 1999. The orbiter approached Mars. Navigation teams prepared for orbital insertion. They calculated the final approach trajectory. The spacecraft needed to pass Mars at 150 kilometers altitude. This was the safe minimum distance. Any lower risked atmospheric destruction. Any higher might cause the spacecraft to miss orbit entirely. Engineers relied on accumulated navigation data. All calculations used the flawed thrust information. The projected altitude showed 150 kilometers. The actual altitude would be much lower. Nobody realized the conversion error existed. The teams trusted their separate systems completely. September 23rd, 1999. 09 UTC. Mars Climate Orbiter begins final approach. Controllers send the last navigation commands. The spacecraft orients for orbital insertion. Its main engine prepares to fire. This burn would slow the orbiter down. It would capture the spacecraft into Mars orbit. Communication continues normally. Telemetry data flows to Earth. Everything appears nominal. Engineers monitor from JPL Mission Control. They expect a brief communication blackout. The spacecraft will pass behind Mars. This is standard for orbital insertion. Radio signals cannot penetrate the planet. The blackout should last 20 minutes. 0906 UTC. The orbiter enters Mars shadow. Communication stops as expected. Controllers wait for signal reacquisition. 20 minutes pass. No signal. 30 minutes. Still nothing. Engineers check their systems. All ground equipment functions properly. The Deep Space Network antennas search for the signal. They scan the expected orbital positions. Nothing. An hour passes. Concern grows. The spacecraft should have emerged by now. Controllers calculate alternate scenarios. Every possibility yields the same conclusion. Mars Climate Orbiter is lost. The mission has failed. But why? Teams begin immediate investigation. Investigation teams form immediately. Engineers review all mission data. They examine navigation files closely. They check thrust calculations. They compare software specifications. The error emerges within days. Lockheed Martin's software used imperial units. JPL's software expected metric units. The conversion factor was never applied. Trajectory calculations were wrong from day one. The orbiter flew 170 kilometers too close to Mars. It entered atmosphere at 57 kilometers altitude. Atmospheric density at this level is fatal. Friction heated the spacecraft beyond survival limits. The orbiter disintegrated completely. No debris remained to recover. $327 million destroyed by unit confusion. NASA formed an investigation board. Arthur Stephenson chaired the review. The report, published November 10, 1999, it identified systemic failures, poor communication between teams, inadequate verification procedures, lack of independent checks, budget pressure, reduced quality control, faster, better, cheaper philosophy backfired. NASA implemented major changes afterward. All spacecraft data now requires unit verification. Independent review teams became mandatory. Software interfaces need rigorous testing. The agency strengthened systems engineering. They improved communication protocols. Training programs expanded significantly. The Mars program survived despite this failure. Future missions succeeded. But the lesson remained clear. Basic errors can destroy complex missions. Mars Climate Orbiter failed because two teams spoke different measurement languages. A $327 million reminder that communication matters more than technology. This was not NASA's only Mars failure. Mars Polar Lander disappeared 2 months later. That mission also cost hundreds of millions. The Mars Observer vanished in 1993. 3 failures in 6 years. Each taught different lessons. Each improved future missions. Mars exploration eventually succeeded. But these disasters paved the way. Subscribe to discover more failed space missions. Learn what went wrong and why it matters.